Turns out we have some ways to solve the time travel paradoxes. Time travel sounds enticing, but brings with us a lot of problems. Take, for example, the famous grandfather paradox. Imagine that you travel back in time and prevent your grandparents from meeting. This alters the course of history. But how? If you erase their encounter, you cease to exist, so you couldn't even travel back in time to alter the past in the first place. There's also the bootstrap paradox. Let's say we travel back in time and give Beethoven his own compositions before he ever penned them. He gets famous for the very music you provided. But where did it originate? Did you start it? Or was it Beethoven who started it? There are many theories about time travel. One of them involves alternate timelines and parallel universes, like in Back to the Future, for example. If parallel worlds exist, we could hypothetically travel in one where the events unfolded differently, while our original timeline stays the same. This is a beautiful and paradox-free approach, but this is pure sci-fi, as we have no concrete evidence of parallel universes. So what scientists are trying to do instead is to figure out whether time travel is impossible in this one universal timeline. We've been exploring this equation for over a decade and created a fascinating concept called a closed time-like curve, or CTC. Imagine taking a path that forms a loop, bringing it back to where it started, but in time. We know that space-time is like a wobbly piece of cloth which can curve and bend when we place heavy objects on it. In some situations, like near massive objects such as stars or black holes, space-time can be curved. Now imagine an object that's so heavy, with gravity curving the space-time so strongly that it literally loops on itself. If this idea turns out to be real, it could suggest the possibility of traveling back in time in our world line. This possibility is fascinating, but it also creates tons of problems, and scientists may have found the ways to solve them. One of the solutions is that doing paradoxical things can be simply impossible. In this scenario, we assume that the universe has some mechanisms of self-consistency. It means that while you can still travel in time, you're restricted in the actions you can take. For example, you may not be able to go back and alter your family's history, but there's nothing inherently illogical about traveling back in time to simply interact with your ancestors. In this scenario, the universe only forbids you to do logically impossible things. Scientists decided to conduct an experiment to check if it works, and the results were pretty terrifying. The experiment conducted involved the creation of a theoretical time machine. This is also called an in-principle time machine. This wasn't a physical device, but rather a quantum simulation. In the simulation, they attempted to send a photon back in time by a fraction of a second and make it interact with its past self. The goal was to find out what the photon will do. Will it destroy its previous self, avoid the interaction, or something else? What happened is that as the photon approached its past self and was getting closer to the point of creating a paradox, the experiment tended to fail more frequently. In other words, it seems like the laws of physics or the fabric of the universe might have some weird built-in mechanisms that prevent time travel paradoxes. In that case, the question is, how does the universe understand what is logically impossible? And how does it prevent us from doing these things? Which is quite scary to think about. There's another theory that the universe allows paradoxical things to happen, but also self-corrects them. Imagine a time traveler going back to stop some health condition from spreading. According to this theory, even if the traveler succeeds, this health condition would find another way to spread, avoiding the paradox. Or maybe we all exist in time loops. These loops allow objects to interact with their past selves while still maintaining a consistent timeline, because there's no beginning point. For example, trying to prevent a historical event could result in accidentally catalyzing the event we were trying to prevent. This idea challenges our understanding of classical physics and free will. But all these ideas are purely theoretical, and to test them, we first need to find the mechanism to actually travel back in time. Talking about practical time travel, we mentioned that space-time curves around very heavy objects. Does it mean that black holes can be portals to the past and the future? Maybe. Black holes are formed when a massive star collapses inward. Their gravitational pull is so intense that even light can't escape. This means they're perfect for bending not just space, but even time itself. You might remember this from Interstellar. Near a black hole, time slows down. This effect is so pronounced that a year near a black hole could translate to decades on Earth. In that case, traveling back to the past using a black hole is theoretically possible. If their gravity twists time so much that it wraps back on itself, creating a closed time-like curve, and you could enter this loop, you'd find yourself on a journey from the future to the past. But there are some problems with this. First, you can only travel into the black hole's past. Second, to enter the loop, you'd likely have to cross the event horizon, the point of no return around a black hole. To escape one, you'd have to travel faster than light, which is currently impossible. So, while black holes might hold the keys to time travel, the journey inside one might be your last. But not everyone agrees that closed time-like curves exist at all. Recent research has shed new light on this topic. The results showed that time can only move forward. The research offered a fresh perspective on how light behaves when it encounters different materials. When light moves through empty space, it travels at a constant speed of 186,000 miles per second. But when it encounters substances like water or glass, its speed can change, causing it to bend or refract. While scientists have equations to describe this behavior, they struggled with the problem of the change of the speed of light at the boundary in different mediums. Well, researchers proposed a solution to this puzzle by reconsidering how light moves through time and space. They figured out that it always remains constant as it travels through different mediums. No matter what the light encounters, it always moves forward in time. This means that light and other waves like it follow the same one-way path through time that we do. Another thing is that light also always saves its momentum, and it always stays the same, pointing forward in time. And finally, even with general relativity and with gravity bending light very strongly, it still keeps pointing forward. It can slow down to the point of feeling like time stopped, but never move backwards. This challenges our previous notions about the relationship between light and time. It implies that time has a definite direction for all waves, making it impossible to reverse. However, their equations have only been tested in one dimension, and experiments are needed to confirm if this theory holds true in reality. Stephen Hawking also disagreed with the idea of traveling back in time. He proposed a theory called the chronology protection conjecture. This idea says that the laws of physics stop time travel on large scales, even when theories like general relativity say it's possible, and that closed time-like curves simply can't exist. Hawking said that traveling back in time would mean creating new matter, which goes against the laws of physics. Although we're far from building actual time machines, if we keep diving into mathematics, we might find the truth one day.
You of course know that the Earth is bathed in sunlight every day. Every day we flicker different light sources on and off, mechanically, without even thinking about it. But imagine that one day you casually flicker the lights off, fall asleep, and wake up in a completely different era. Let's see how it happened and what it has to do with light. Quantum physics is quite crazy. Classical physics is like a movie projected from start to finish, while the quantum world is like having an ability to take the remote control and manipulate scenes you're watching. Fascinating and mysterious. Let's say you have a regular light switch that can be either on or off. That's like a regular bit in computers, which can be in one of two states, 0 or 1. But in quantum computers, there's a special kind of switch, a switch called a qubit. Unlike the regular bits, A qubit can exist in multiple states at the same time. It can be both 0, 1, and all things in between, like having lights on and off simultaneously. Yeah, our universe has some weird rules. This mysterious property, called superposition, allowed us to do something incredible recently: to reverse time back. At least in a tiny experiment with quantum computers. It's the autumn of 2022. Two groups of scientists, one from Oxford and the other from Vienna, decided to conduct a weird experiment. They played around with a quantum computer to create a program that reverses time. They took a tiny electron and tried to make it go backward for a time for just a fraction of a second. It would be like breaking a billiard ball triangle, where the balls go from order to chaos and then magically reverse. But don't get too excited about time travel yet. Unfortunately, we're not sure if it's possible to recreate it in real life. The scientists cracked some numbers and found out that if we observe 10 billion localized electrons every second for the entire age of the universe, we'd only see something like this happen once. And it would only take the electron back a tiny fraction of a second. So they didn't invent a time machine. They just managed to create this simulation in quantum computers. There's another catch too. The larger the simulation, the more complex and less accurate it becomes. In our experiment, we only used one qubit and we managed to reverse time. In a 2-qubit setup, scientists could reverse time only in 85% of cases. And in a 3-qubit setup, it dropped to 50% with more errors. If we keep adding more qubits, we won't be able to pull this off at all. Plus, the success depends on the amount of information the system can store. For example, teleporting a person would be almost impossible because humans have so much information inside them. So, unfortunately, no time machine so far. But there are some possible uses of this discovery. Reversing qubit states in a quantum computer can help correct errors during development, sort of like a little Control-Z in real life. So, it was a tiny step to more exciting discoveries in the future. For example, recently they demonstrated another crazy little thing: send light itself back in time. Now, light isn't mere luminary. It has superpowers that we can't even imagine. The ancient Greeks believed that our eyes emitted visionary beams. Sir Isaac Newton proved them wrong hundreds of years later when he conducted his experiments with prisms. The prism broke the pure white light into a beautiful palette, and that's how we found out that light actually consists of tons of different colors. Many years later, scientists learned even more, that light is a wave. And even later, in the 20th century, we discovered the final paradox, that it's both a wave and a particle, a dual existence in one photon. And the more we learn about light, the more crazy things we find. In 2016, scientists managed to freeze the light in time. They put photons, the tiniest light particles, in ultra-cold atomic clouds. Then they managed to stop it, again, for just a moment. But the fact that it's even possible is already incredible. Then scientists got even bolder. They decided to try not only to freeze the light, but to move its direction in time. They took a special crystal and passed a photon through it, thus initiating the so-called quantum time reversal. As a result, the photon started moving into both the future and past at the same time. The science magic behind this involves two quantum principles: superposition and quantum symmetry. We already mentioned the first one. It allows tiny particles to exist in multiple states at once. Now, the second principle says that even if you flip particles around like a mirror, they'll still follow the same laws. Combining this, scientists crafted a photon that defied the usual forward march of time. But again, it's nothing super fancy yet. This time flip only works for specific particles, not entire humans. And even if it did work for us, rewinding a person even for a second would take a super long time and a lot of energy. But the fact that we can change the light's speed and make it change directions is already amazing. And scientists already see some possible applications to this. For example, Harvard researchers suggest a cool way for spacecraft to zip through space at the speed of light, by hitching a ride on supernovas. Usually, traveling to other stars takes an insane amount of energy, but these scientists have a wild idea. They think that spaceships could use natural events like hypervelocity stars and meteors zooming from supernovas to reach superfast speeds. It's kind of similar to how sailing ships catch the wind. Advanced civilizations could use these energy bursts to speed up their spacecraft. Imagine a cool spacecraft with solar or magnetic sails harnessing the power of a supernova boom. These sails could use the pressure of the sun's radiation to work, so that we wouldn't need any traditional engines or fuel. Plus, these sails concepts are much lighter and cheaper to launch into space compared to regular spacecraft. The team is already working on a light sail accelerated by lasers to reach 20% of the speed of light. It might not sound like a lot, but it's actually an insane speed. Their dream is to help humanity make a swift journey to Alpha Centauri in just 2 decades. Isn't it amazing how many things we can do with light, and not just in our imagination? Let's go to more practical achievements. Recently, a Canadian camouflage company called Hyperstealth Biotechnology Corporation has crafted an actual invisibility cloak. The wizardly cloak doesn't need any power source, is as thin as paper, and won't break the bank. Hyperstealth envisions a world where this material can cloak people, vehicles, ships, spacecraft, and even entire buildings. It's still in a prototype phase, but it already works pretty well. They name this incredible technology quantum stealth. It bends light in a way that can make objects disappear from sight. It can render objects nearly invisible, not only in the visible spectrum, but also in ultraviolet, infrared, shortwave infrared, and it even throws in thermal spectrum blocking for good measure. The technology works thanks to the lenticular lens, a corrugated sheet with outward curving lenses. When stacked in a specific way, these lenses refract light at various angles, creating spots that block light and conceal the object behind the material. Unfortunately, it doesn't give you a full invisibility effect, but maybe someday we'll achieve it, if we keep working on it. If you hide behind it, it will look like a little dirty or blurred glass, but you won't be visible. If you put this veil in front of your body, you'll look like a floating head. Scientific progress is in full swing. Maybe one day we'll be able to reverse time not only for little light particles, but for entire humans. Until then, let's enjoy our invisibility cloaks and stay curious. Okay, so you've seen the movies and read the books on time travel. Most of them tell stories about entering some futuristic boxes, and in the blink of an eye, you're in some different epoch. For now, this is just sci-fi. But there are ways to make time travel possible, at least theoretically. We just don't have the technology figured out yet. For starters, time travel to the future could be achieved by traveling at high speeds, but not just getting a ticket on the superhighway kind of speed. This is based on Einstein's theory of special relativity. It explains that time slows down for objects that move at really high speeds. And the good news is scientists have already tested this theory, and it looks promising. They did it with the help of 2 identical clocks. One was placed on a jet, and one stayed on the ground. They found that the clock on the jet ticked slower than the one on the ground because of how fast the jet was moving. The faster an object is moving, the more time will slow down for it. Currently, the fastest speeds achieved by human technology are seen in a special type of particles called neutrinos. Some of these can move at almost the speed of light. At these speeds, 1 second for the protons is equal to 11 months for us. Now, we might be able to time travel to the future with the use of gravity, too. This idea is based on Einstein's findings, namely his theory of general relativity. Now, this theory explains that the stronger gravity is, the more slowly time moves. This means that as you get closer to the center of the Earth, the strength of gravity increases. And if you think about it like that, time actually passes more slowly for your feet than for your head. Now, is that why I'm always late for stuff? Good excuse. This effect has been measured too, with the help of the same strategy with 2 identical clocks. Scientists placed them on shelves at different heights and measured the rate of ticking. The clock on the lower shelf ticked more slowly because it experienced a slightly stronger gravity. But this option comes with a catch. To be able to travel to the far future, you'll need to find a place with extremely strong gravity, like a black hole. That's a point in space where the gravity has so much force that even light cannot escape it. There, gravity becomes so intense that matter gets squeezed into a tiny space. The closer you get to the black hole, the more slowly time moves. However, traveling via a black hole is very dangerous, mostly because it's a one-way ticket. Once you cross its edges, there's no coming back. Now, here's a fun fact. The GPS systems we use on our phones and in our cars already have to account for time dilation effects in order to work properly. That's because of the speed of the satellites they use and the gravity they feel here on Earth. Without these corrections, your phone's GPS wouldn't be able to pinpoint your location on Earth very precisely. Meanwhile, the third option has less to do with the universe's unknown forces and more to do with our own bodies. Scientists are trying to find ways to time travel to the future by slowing down the body's own processes. It's not time travel per se. You wouldn't technically be going anywhere. But if your body stays put for a long period of time, you could eventually wake up in the future. Some animals, like bears and squirrels, can slow down their metabolism during hibernation, which means they don't need as much food and oxygen to survive. Specialists are trying to figure out if humans can do the same thing. They're working on ways to make people go into a short-term hibernation for a few hours to begin with. This could be helpful for medical emergencies too, in order to help a person before they can safely get to the hospital. In 2005, scientists were able to slow down the metabolism of mice by exposing them to a small amount of special gas. However, when they tried to do the same thing with larger animals, it did not work as effectively. Our fourth option of traveling through time is really unique. It involves a special type of shortcuts that may exist in our universe called wormholes. Now, before we move on, let's try to understand what they are. You'll need to picture two balls and a trampoline. If there's no pressure applied on the trampoline, it stays flat. Now imagine the two balls placed on the trampoline symmetrically. If you look at them from this perspective, there's no possibility of them ever touching. But if you put enough pressure on the trampoline between the two balls, this flexible fabric can stretch so much that the two objects might potentially touch each other. The same thing happens with stars in different star systems. They're big enough to curve space around them. That's why most planets tend to orbit around a star. The tunnel between those 2 points would be a wormhole. These wormholes could be used to travel long distances, like 1 billion light years, or even visit different times. Now, many scientists, like Stephen Hawking, think that wormholes might appear and disappear, but be very small, smaller than atoms. The problem is that we don't know how to catch one and make it bigger so that people can use it. This would take a lot of energy, and we don't know if it's even possible. Some astronomers say that even if we could find a wormhole and enter it, it would rapidly collapse on itself. Even the tiniest bit of extra mass, like that of our bodies for example, can result in the wormhole slamming shut, like a rubber band that's been stretched too much. Now, the fifth solution for time traveling was proposed by an American physicist named Ron Mallett. It involves one resource that we know for sure is abundant in the universe: light. The scientist proposed a theory about time travel that would use a rotating cylinder of light. He believes that if something was dropped inside this swirling cylinder, it could be moved in both space and time, similar to how a bubble moves when you swirl it with a spoon in your coffee. According to Mallett, the right shape of the cylinder could allow for traveling to both the past and the future. The physicist has been trying to raise money for an experiment to test his theory. This experiment involves dropping tiny particles, called neutrons, through a circular arrangement of spinning lasers. However, other scientists say Mallett's theory is impossible and there's no need to test it further. Well, even if we eventually figured out a way to travel back in the past or to the future, would it be safe? Scientists have been talking about a problem called the paradox of time travel for a long time. The main question is what would happen if you went back in time and did something that changed the future. However, a new study from researchers from the University of Queensland says that this problem might not be real after all. The scientists have done some calculations and found out that even if you had changed something in the past, the timeline would still end up the same way. Another variation of this problem is called the grandfather paradox. Imagine going back in time and preventing your own grandfather from having offspring. Come to think of it, it automatically means you shouldn't exist in the first place. If your grandparents didn't have your parents, how can you exist at all? Well, these days scientists are certain that even if you did experience something like that, you'd still exist in the present. That's because the timeline that already exists has a way of adjusting itself, regardless of where people are in time and what they do. Or somehow get 1.21 gigawatts in a DeLorean and make like Marty McFly. Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now, imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction, but it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, this idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to it, the universe is made up of more than just the 4 dimensions of space-time. There are additional dimensions that are hidden from us. Plus, the basic building blocks of the universe aren't particles, but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor: gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction. Ooh, you're on a beautiful planet with unusual nature. Around you are ordinary people walking on this exotic planet. And now, get this, it's our new home. Humanity decided it was time to leave the Earth, and now we live very far away in another galaxy. But what happened to our home planet? Well, our solar system itself had an expiration date. It's been 7.5 billion years since 2020, and the Sun began to expand, absorbing planet after planet – Mercury, Venus, Earth. But the living conditions on Earth were unsuitable for us long before that. Let's go back there. In 4.5 billion years, our entire Milky Way galaxy will experience an incredible incident. The Andromeda Galaxy will hit us at great speed. As a result of the collision, some stars will be thrown into distant space, while others will form new solar systems. But most likely, all life in the new Milkomedia or Milkdromeda galaxy will cease to exist. That's why people decided to pack up their things, get into new generation spacecrafts, and go to distant space in search of a new home. There can be an infinite number of planets in the universe on which humans can theoretically live. One of the main ingredients, the planet must orbit the star in its habitable zone. This means the temperature must allow the water to be liquid. We find similar star systems almost every year and have recently found the nearest one. It's Proxima Centauri. There are at least 2 planets around this red dwarf on which we can build our new home. But the problem is that this system is as far as 4.2 light-years away. So we had to open our garage and choose a vehicle that could take us so far. Saturn V is a rocket that used to take humans to the moon. It could reach the speed 30 times faster than the speed of sound. Today, we have more advanced technologies, like the SpaceX Falcon Heavy rocket. However, its speed is still about the same. It would take such a rocket about 113,000 years to overcome the distance to the closest star. So, you walk through the garage further and see the fastest human-made space object ever, the Parker Solar Probe. Its speed is a little less than 500,000 miles per hour, but it uses the gravity of the Sun to accelerate. Let's assume we can build a rocket that can reach this speed. Now, we sit behind a star map, do calculations, draw diagrams, and 6,600 years. And now, let's look at the photon. These are the tiniest particles that travel at the speed of light. And an obvious thought comes to your mind. How do you build a ship that can travel as fast as a photon? Well, until recently, travel at this speed was considered impossible. Fundamental laws of physics say that no object that has a mass can accelerate this much. Energy is required to accelerate mass. And to reach the speed of light, which is about 186,000 miles per second, we need an infinite amount of energy. But it's still too slow. Raise your eyes and look at the Sun. It's so close to us, but the light from it reaches our planet in 8 minutes, about the time it takes to go through the drive-thru and get your burger. And the journey to the nearest star will take 4.2 years. You can graduate from college during such a period. But we may have found a way to cheat the laws of physics and travel faster than light. Warp drive. It's a technology that manipulates space and time to break the laws of motion. In science fiction, it's a kind of field that envelops a spacecraft like a bubble or a shell and allows it to significantly exceed the speed of light. And we already have a similar technology, sort of. It's the Alcubierre warp drive. Since it's impossible to move at the speed of light in normal space-time, the ship must move by compressing the space in front of it and expanding it behind it. So not only the ship itself moves, but so does the space-time inside this bubble. In fact, this will allow the spacecraft to move at any speed, even 10 times faster than the speed of light. But to warp space-time, the ship must be simply humongous in size. It will need the quantity of energy comparable to the amount of mass energy of the whole planet of Jupiter. But at recent symposiums, scientists began to say that there is hope. In 2069, NASA plans to launch an interstellar mission to explore inhabitable planets outside our solar system. We do not yet know the details of this mission. It doesn't even have a name yet, but it will be dedicated to the 100th anniversary of the Apollo mission, the first man landing on the moon's surface. Here, near Pasadena, California, a small group of scientists from NASA's Jet Propulsion Lab are trying their best to make it happen, and their latest calculations have made everyone shout Eureka! It turns out the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round as it was thought before. It's more like donut-shaped. This will greatly simplify the design and construction. And the best part, to test this technology, a spacecraft the size of Voyager 1 probe will suffice. Researchers are now aiming to reach at least 10% of the speed of light and launch the probe to Alpha Centauri. In this case, to overcome the distance of 4.4 light-years, the probe will need about 44 years. For comparison, the Voyager 1 mission was launched on September 5, 1977. In 43 years, it's traveled about 14 billion miles and is the most remote human-made object. It's also the loneliest one in the universe. It has long since left the boundaries of our solar system and is moving further into outer space. But rest assured, scientists have a couple more ideas in their secret laboratories. There are rumors now that they know how to reach the speed of light. The Space Association is considering launching small drones powered by lasers. Nuclear force, as well as collisions of matter and antimatter, can give enough energy to accelerate an object to the speed of light too. But their colleagues in a nearby laboratory are working hard to implement another technology, ion propulsion. It uses gas particles accelerated by the electric field. Simply put, your regular rocket is a daredevil on the road. He pulls the throttle to the max and burns an incredible amount of fuel to accelerate to the speed he needs. But ion propulsion is a careful old lady driving. She slowly presses the gas pedal and accelerates. On the scale of space, the old lady will have more efficiency and will be able to drive much further than the daring young man. Something we'll keep an eye on. Still, an unknown number of years will pass until there's a way to implement warp drive or ion propulsion. We want to make humankind interstellar, but first, we need to keep it alive at least. Now we're actively developing technologies to send the first manned mission to Mars. Colonization of Mars will be the first stage to make our species interstellar. It'll be a kind of rehearsal before colonizing distant planets. We must understand that although the conditions on the exoplanets may be close to earthly ones, we will still have to terraform them. We must test our technology on Mars to warm it up to the normal Earth temperature. We also need to increase atmospheric pressure so that water could exist in a liquid state, and create an ozone layer that will protect us from solar radiation. After that, we'll be able to breathe freely on the surface of Mars without spacesuits. We need to master all these technologies before we can create a real warp drive. Centuries ago, people sailed the oceans and perfected their ships to fully explore our planet. Now, we will be the generation to build new ships and go on long journeys outside the Earth. Warp drive will open up incredible horizons for us. Take a look at our galaxy. There are countless stars. Around each of them may be planets, and on some of them, there may be life. Warp drive will allow us to get in contact with this life and explore our galaxy much faster. And this future is already close. Soon, we'll have the chance to join the pioneers, put on beautiful suits, and travel the expanses of space in search of adventure.
Imagine that it's the year 2025, and our planet has completely changed. Rising sea levels, extreme weather, and the ocean becoming more and more acidic are just some of the problems people have been dealing with for years. But in one of the world's largest coastal cities, the situation has become too serious. It was a sunny day in June when a massive earthquake shook the city to its core. The ground beneath people's feet heaved and shook, and buildings swayed dangerously. People ran through the streets in panic, trying to find safety. But as soon as the ground settled, the inhabitants of the city realized the real danger. A wall of water, almost 100 feet high, was rushing toward the city, propelled by the force of the earthquake. The tsunami hit the city with unimaginable force. Entire neighborhoods were wiped out, and thousands of people lost their lives. But here's where things get interesting. In the aftermath of the disaster, the city's authorities realized that they couldn't just rebuild the city as it was before. They needed to be better prepared for the next potential disaster. And so they came up with an incredibly ambitious project to build an underwater city. The goal was to create a self-sufficient, sustainable city beneath the ocean's surface, that could withstand any natural disaster. The underwater city would be powered by renewable energy, using tidal power and underwater solar panels. It would be designed to withstand extreme weather and would have its own emergency response systems. The project attracted some of the world's top scientists, engineers, and architects. They worked tirelessly to design the city and carefully considered every aspect of the project. The underwater city would have everything that a typical city had, from schools and hospitals to stores and restaurants. There would be underwater farms where fish and other marine creatures could grow. The city would even have its transportation system, advanced submarines, and underwater tunnels connecting different parts of the city. The project became a shining beacon of hope for people. It showed that even in the face of disaster, we could come together to create something amazing. But as time went on, the project no longer seemed so perfect. The cost of the project turned out to be higher than planned. There were also concerns about how long such a project would exist. After all, the ocean is very unpredictable. And still, the team of scientists and engineers never gave up. After years of trial and error, they finally created the perfect underwater city, a marvel of engineering, a self-contained ecosystem that could sustain people indefinitely. The buildings were constructed from a material that could withstand the immense pressure at the bottom of the ocean, and the city itself was powered by a network of advanced hydroelectric turbines. It wasn't long before the first wave of colonists arrived at the underwater city. There were different people in this group, and each of them had their own reasons for choosing to live in this new world beneath the waves. Some were adventurers seeking a new world to explore, while others were hoping to escape natural disasters raging on dry land. But despite their differences, all these people shared a common goal: to build a new society, one that was in harmony with the natural world. The underwater city flourished, and new discoveries were made every day. The colonists developed new technologies and ways to tame the power of the ocean. They learned to farm the sea and started cultivating underwater gardens that provided them with a steady food supply. But living underwater was challenging. People felt isolated and even claustrophobic. The situation came to a head when a group of activists started to protest against the city's expansion plans. They argued that the underwater city was a threat to the environment it was meant to protect, and that the colonists should focus on reducing their impact on the delicate underwater life. The protests sparked a heated debate among the colonists. Some of them argued that the survival of the city depended on its growth and expansion. Others claimed that the city needed to prioritize the protection of the environment above all else. In the end, a compromise was reached. The city would continue to expand, but the main priority would be sustainability and a responsible attitude to nature. The colonists would do their best to reduce their impact on the environment by using new technologies and following strict conservation rules. And they would also remember the importance of protecting the ocean and its fragile ecosystem. Years went by, and the underwater city continued to thrive. New generations of colonists were born, and they grew up in a world entirely different from the one their ancestors had known. They never saw the world on the surface, but appreciated the beauty and complexity of the underwater world they called home. And as the years passed, the city became a symbol of hope for a world struggling with the devastating effects of climate change. It showed that despite all difficulties, people could come together to create a better world. It is a reminder that the future is not set in stone, and that we can build it sustainably and in harmony with the natural world.
About a century ago, people envisioned the 21st century as a time filled with quirky inventions. They weren't far off the mark. We're now one step closer to establishing an actual settlement on the moon. Before we can create a new home up, we need to find a way to stay connected, beyond just transportation and shipping. Being able to send a simple text, even something as casual as, "Hey, how are you?" is essential. We can't move to the moon if we're cut off from Earth. Let me spill some tea. A lunar 4G network is currently being developed. The company leading this initiative is none other than Nokia's Bell Labs. The company, bought by the world-famous Finnish company that started out as a paper mill in the 19th century and later ventured into the cell phone industry, creating iconic devices long before Apple launched its first phone. Once the network is completed, It will be loaded onto a lander, deployed, and connected using specialized radio equipment. But don't think this is just a fun experiment. It has significant purposes. The Lunar Outpost rover, one of the vehicles involved in this mission, will thoroughly explore an area known as the Shackleton Connecting Ridge. Another rover, the Micronova, will investigate a lunar crater in search of ice. When they discover ice and capture images, this information will be first transmitted to the lander and then relayed to Earth, an unprecedented achievement in history. Moreover, the importance of a reliable phone connection cannot be overstated. Currently, astronauts communicate via radio. But NASA aims to establish a lunar communication system capable of supporting high-resolution video. Effective communication during space missions is as crucial as food and water, and with this new lunar 4G technology, video calls on the moon could soon become a reality. Plus, thanks to lunar 4G, we'll be able to track how the endangered species sent to the moon are doing. Oh, sorry, I completely forgot to mention something important. As more species edge closer to extinction today, scientists are collecting samples from animals, plants, and other organisms to store in biorepositories around the globe. Unfortunately, the conditions on Earth are far from ideal for these modern-day Noah's Arks. Hence, the decision to build 1 or 2 vaults on the moon makes perfect sense. On the moon, there's a permanently shadowed region at its south pole. It may seem like a fortunate coincidence, but some lunar craters may meet the criterion of temperature, -320 degrees Fahrenheit, which is precisely what we need for long-term self-storage. Initially, the plan was to construct the vault in lava tubes that run beneath the moon's surface, but that would have posed significant risks. This design requires a special solar-powered cooling system, and any accidental loss of power could be catastrophic, resulting in the destruction of all the samples. However, if we built it in a forever frozen shadowed area, the vault wouldn't need any energy or human maintenance. Bingo! It sounds almost too good to be true, and indeed there are several complications. For instance, dust is an omnipresent issue on the moon, infiltrating everything. If the storage requires seals, a dust mitigation system must be developed, which has not yet been created. So for now, it remains a theoretical concept rather than a practical solution.
40, 50 feet, why don't you turn around and let them get a view from there and...
I know you want to learn about real things, not just concepts. Here's something real for you. The moon is full of human waste, carefully packed into bags. According to estimates, there are around 96 of these bags you'd probably prefer to never open. But you never know what exactly is hidden inside. It could be any product of the human body out there. So, if we ever make it to the moon and you accidentally stumble upon a mysterious bag, my advice is to resist the urge to open it. Instead, you can hand it over to scientists. They say they're eager to get their hands on them. Humans are incredible, in a rather unfortunate way. We haven't even established a proper settlement on the moon yet, but there's already around 200 tons of junk scattered about. It piles up there as if it were a teenager's room rather than a celestial body. Alongside those rather unappealing human waste bags, you'll also find cameras, drills, towels, brushes, rakes, a multitude of other technical items, and, surprisingly, a falcon's feather. I'll explain that in a moment. At the end of Apollo 15's final moonwalk, David Scott pulled out a falcon's feather and a hammer to demonstrate Galileo's theory that in the absence of air resistance, different objects fall at the same rate. Amidst all that junk, there's an actual piece of art, so we could say that the moon, if it doesn't have the very first art museum, at least boasts a small exhibition. The crew of Apollo 15 took a 3.5-inch tall aluminum figure to the moon. Created by a Belgian artist, it's called the Fallen Astronaut, and it was laid on its side with a plaque listing the names of astronauts and cosmonauts who contributed to exploration. But the list of odd objects on the moon doesn't end there. If you ever find yourself in need of cash, You can find it on the moon, since a stack of $2 bills was simply forgotten there. Yep, a lot of material has been collected since 1969, when humans first stepped on the moon.
It's one small step for man, one giant leap for mankind.
Our natural satellite was first seen in a telescope in 1609. But what about its true age? To understand that, we need to start with how the moon first formed. Back in the mid-80s, a conference in Hawaii brought together a bunch of scientists to figure out where the moon came from. They came up with a pretty cool idea. The moon probably formed with the stuff that our planet Earth donated. Picture this. A Mars-sized object crashed into the early Earth, flinging molten materials into space, which eventually came together to become the moon we see today. This theory clears up a lot of mysteries. For instance, it used to baffle folks why the moon has such a small iron core. The answer is simple. It formed from Earth's outer layer, which isn't rich in iron. And that pale crust of the moon? It's just minerals that floated to the top when the molten moon cooled down. At first, the moon was super close to Earth, but it's been slowly drifting away at about 2 inches a year, even while you're watching this video. Figuring out when this all went down, though, is a bit tricky. The Apollo astronauts brought back a bunch of moon rocks, which helped scientists estimate their ages. The oldest ones are around 4.35 billion years old, which is about 200 million years after the solar system kicked off. So, here's the thing. There's no exact date for when the moon formed, but there are several interesting theories. One idea is that the age of these rocks could mean the moon is around 4.35 billion years old. But some scientists who look at how planets form think that most of the material in the early solar system came together way before that 200 million year mark. They argue that a big impact that created the moon happening that late seems pretty unlikely, which means the moon could actually be older than 3.5 billion years. Another interesting thought is that the moon might have gone through some serious heating events as it moved away from Earth. This is similar to what happens on Io, one of Jupiter's supervolcanic moons. The gravitational pull from a bigger body can stretch and compress a smaller one, generating heat, like when you squeeze a rubber ball. The rocks on both Io and the moon warm up this way. Rocks have radioactive elements that act like internal clocks, helping scientists figure out their ages. The catch is, if the moon heats up too much, it resets those clocks and only starts keeping time again once it cools down. So those rocks that are about 4.35 billion years old might not actually mark the moon's birthday. They could just indicate a time of tidal heating. This suggests, once again, that the moon had to have formed even earlier than that.
Have you ever wondered how cool buildings of the future are going to look? Well, hold on tight because artificial intelligence is here to revolutionize the world of architecture. AI is a great sidekick. It can give the architects incredible new tools to create mind-blowing structures that are not only stunning, but also eco-friendly and super efficient. So let's check what our beautiful future might look like. First of all, you know how cities can get crazy busy and overwhelming, right? Well, guess what? AI is here to save the day and make our cities super smart. Imagine you're cruising down the road in your flying car. Yes, we'll have those. Thanks to AI, the traffic flows like a dream. No more endless gridlock. The city knows where the most likely crime spots are and takes proactive steps to keep us safe. It's like having superheroes on every corner. And hey, forget about trash piling up. AI makes sure waste is managed efficiently, keeping our city clean and fresh. They can act as a city manager who can optimize everything from traffic to safety and even waste disposal. They can analyze tons of data from all sorts of places like sensors and social media. With all that information, they can help city planners make brilliant decisions that make our lives better. Okay, so you stroll down the street, and your eyes are instantly captivated by an extraordinary building. Its futuristic curves and features make it stand out from the rest. And it not only catches your eye, but also gives Mother Nature a high five. You might think it was designed by a genius architect, but little do you know it was actually a collaboration between humans and artificial intelligence. Imagine Imagine having a super smart design buddy who can whip up thousands of incredible building ideas in a blink of an eye. That's what AI-assisted design software does for architects. It can generate and assess a ton of design options. They take into account stuff like the best materials to use and the perfect placement for the building. Also, by analyzing data and crunching numbers, algorithms can help optimize the building's design. They can ensure it minimizes energy usage, conserves water, and manages waste like a pro. Every building strives to reduce costs, save energy, and promote a better world. The result? Architectural masterpieces that are both jaw-droppingly beautiful and super practical. The cityscape of the future will be dotted with these awe-inspiring structures. Oh, but that wasn't impressive enough for you? Well, how about a stunning, futuristic building that seems to defy gravity? It's not made of traditional bricks and mortar, oh no. This marvel was created using the powers of 3D printing. With the help of AI, architects designed every intricate detail and fed all the important data, like what materials to use and how the site conditions might affect the structure. AI algorithms worked their magic to optimize the design, making it both breathtakingly beautiful and rock solid. 3D printing is basically like having a magical machine that can create awesome structures straight out of a sci-fi movie, and AI jumps in to make sure these structures are not just pretty, but also strong. In the city of the future, 3D printing will become the ultimate architect's tool. It will allow them to create structures that were once impossible to build. From mind-bending shapes to intricate details, the possibilities are endless. But AI isn't just making buildings look great, it also makes them efficient and cozy. Let's say you step into a futuristic office building, and voila! The lights automatically adjust to match your mood, and the temperature is set perfectly for you. These futuristic buildings are capable of sensing and responding to their surroundings, just like you do. They control the lighting, keeping it just right for the time of day. They manage the temperature, so it's always cozy and comfortable. They even keep a watchful eye on security and fix small issues before they become big headaches. So, the smart building knows when people come and go, so it optimizes energy usage accordingly, saving the planet and some cash along the way. Now the cool thing is, all these aren't the only possibilities. How about turning skyscrapers into a vertical forest? Recently, an architect from India got super excited about the power of artificial intelligence. So, he decided to team up with an image bot called Midjourney to create a vision for the future. But instead of a dull, robotic world, they aimed for something spectacular. With text prompts like utopian technology and futuristic towers, the architect and AI got to work. Guess what? Midjourney didn't disappoint. It conjured up a world where buildings were covered in lush vertical forests and adorned with shapes inspired by nature. They wanted to create a sustainable future that harmonized with the environment. The architect, Manas Bhatia, is super positive about AI's potential. He doesn't see it as a threat to his job, but as a powerful tool for positive change. He envisions a future where architects and AI collaborate to make breathtaking designs. In his project, Bhatia even asked the AI to imagine symbiotic and hollowed structures, and it responded with pictures of apartments nestled within hollowed-out trees. Imagine a world where the building itself becomes a living, breathing part of nature. Well, Bhatia believes that nature should play a big role in architecture. He loves designing structures that embrace nature's beauty and functionality. From buildings built around trees to facades that regulate temperature, he's all about blending architecture with the natural world. With architects like Bhatia and the superpowers of AI, the future of cities is going to be amazing. So get ready to step into a world where nature and technology coexist in perfect harmony. It's a dream we can't wait to see come true. Or if you're not a big fan of trees, how about this? Skyscrapers that aren't made of solid bricks, but instead, they're inflatable wonders. Zumo, an architectural practice in Barcelona, used the magic of AI to bring these wobbly structures to life. These inflatable superstructures rise above future cities like illuminated balloons in the sky. Here's the best part. These inflatable buildings have sustainability superpowers. You can pump them up to towering heights, flatten them for easy transportation, and rebuild them wherever they're needed. Plus, they're powered by renewable energy, reducing their impact on the environment. Pretty cool, right? Phew. The future is zooming toward us like a rocket. Artificial intelligence can become the secret sauce that makes architects' work extra special. But hey, with great power comes great responsibility. We need to use AI wisely and ethically. For now, we don't have to worry about machines replacing architects. Artificial intelligence still needs a human hand, or else we might end up with buildings that look like mashed up bananas or ice cream cones, unless that's your thing. In addition, humans have one important advantage. They, well, are humans. We need to keep in mind that artificial intelligence doesn't have emotional intelligence. It's a brainy genius, but it can't fully understand the feelings and vibes we humans crave in our spaces. So, we must remember to infuse our designs with that human touch, those warm and fuzzy elements that make us go, "Ah, I feel right at home." And let's not forget that AI is still learning. It's basically just taking its first steps, and we need to be patient and give it time to grow. Rushing things too quickly could lead to wonky designs or buildings that look like a jumbled puzzle. This might look cool if you like avant-garde architecture, but for regular folk, no thanks. So, as the future unfolds at warp speed, let's embrace the wonders of AI in architecture. But let's also remember to balance its brilliance with our own human touch. Together, we can create a future where buildings are not just functional, but also filled with heart and soul. It's an adventure that's out of this world.
Alright, so our universe is 4-dimensional. 3 dimensions are for space and 1 is for time. Now, let's mix them together. We're getting a nice dough called space-time. This dough has one amazing feature. Even though you can't use it to bake a pie, you can bend and tear it. Now, forget about our culinary analogy. We're going to space. Waves traveling through space-time can travel at speeds much greater than the speed of light. Now, when it comes to propulsion, or simply put, moving forward, traveling through space by ejecting hot gas from the back of your spacecraft is not the most efficient approach. But a much more elegant way is to manipulate the fabric of space-time around your ship. That's how we get to the topic of the Alcubierre warp drive. So far, it's just a hypothetical concept, but who knows? Maybe in 10 or 20 decades, we'll use this device to visit our relatives who have moved to the other side of the Milky Way. Anyway, the warp drive theoretically contracts the space-time in front of a spacecraft, simultaneously expanding the space-time behind it. It allows the ship to move from one point to another at an insanely fast speed. While the spacecraft would be distorting space-time, someone outside the ship's warp bubble would observe it moving faster than the speed of light. At the same time, if you were that lucky traveler inside the ship, you'd feel no acceleration whatsoever. If we could make such a superluminal warp drive a reality, superluminal, which is a fancy word to describe something faster than the speed of light, it would change our lives for good. It would enable us to travel all over our solar system and perhaps help us reach neighboring star systems as well. For example, we could get to Alpha Centauri, the closest to a star system located a bit more than 4 light-years away, within days or weeks instead of thousands of years. Unfortunately, I gotta quench your enthusiasm, my friend. The warp drive has a huge problem. The force behind its operation, which is called negative energy, involves pretty exotic particles. Even worse, they're completely hypothetical, and as far as we know, don't exist in our universe. Scientists have only managed to describe them in mathematical terms. These exotic particles behave in unexpected ways. For example, they have negative mass. Boy, I wish I could pull such a trick after a big family dinner. And they work in opposition to gravity. But wait, there's still some hope left. A new discovery might solve this seemingly unmovable roadblock. Researchers from New York City have envisioned a positive energy system that does not mess with the known laws of physics. The authors of the study claim that it's a game changer and could be the first chapter in the manual for interstellar travel. You see, this positive energy makes all the difference. Now let's say you're an astronaut on a spacewalk and you decide to play tennis out there. So you push the ball away from you. But instead of floating away, the ball pushes back. And this confrontation can continue to the point that it might take your hand off if you apply enough force. Now, that's a quality of the negative energy the warp drive needs. But as you can see, there's no way to harness this energy, and it sounds rather dangerous. That's why we should probably turn to good old positive energy for the construction of the warp bubble. This bubble is a spherical structure surrounding a spacecraft using a shell of regular, albeit super dense, matter. The bubble propels the spacecraft forward using the powerful gravity of the shell. But the passengers inside the ship don't feel any acceleration. An elevator ride is apparently more eventful than hurtling through space in such a bubble. All because of the immense density of the shell and the pressure it would exert on the interior if controlled properly. And since nothing can travel faster than the speed of light, according to the theory of general relativity, the bubble is designed in a way that those inside could experience normal time. At the same time, the bubble compresses the space-time in front of it and expands it behind the ship, just like that warp drive that uses negative energy. It allows it to ferry itself and the craft unbelievably fast. The walls of the bubble produce the necessary momentum, just like the momentum of balls rolling. If you decided to take up the task of controlling a warp bubble, it would require a great deal of coordination. Such bubbles need enormous amounts of matter and energy to keep passengers safe and maintain the correct passage of time. Plus, communication between people inside and outside the bubble would become super distorted during the passage through the curvatures of warp space. Now, of course, there are still tons of problems researchers need to deal with before finally building a working warp drive. But some of them claim that the model should eventually get close to the speed of light. But even if it remains below the speed of light, it'll still be a great improvement compared to our today's technologies. Hey, see for yourself. Traveling at even half the speed of light to Alpha Centauri would take 9 years. In contrast, Voyager 1, which is currently traveling at 38,000 miles per hour, would need around 75,000 years to reach our neighboring star system. There are some more things to consider. As you approach the speed of light, things get really weird. For example, the faster an object moves, the greater its mass becomes. And this mass can increase infinitely, so that the object will need an infinite amount of energy to maintain its speed. Another issue, current models allow a stable warp bubble only for a constant speed. But then, how are you supposed to accelerate at the beginning of your journey? And what should you do when you eventually need to slow down and stop? Experts claim that the process of the creation of the warp drive is like trying to figure out the concept of the automobile for the first time. We can compare the stage at which the warp drive technology is with the car technology at the end of the 19th century. At that time, automobile travel was possible, but it looked like a tricky process not everyone could deal with. Now, the whole warp drive idea is to stretch and squeeze space to zip around the universe. Well, there's a theory that's even wilder. What if, instead of bending space-time, we just ripped it? Think about it like this. When you bend space-time, you still have to deal with all the stretching and compressing. It's like folding a paper map. You still have to drag your finger across the folds. But try ripping the paper in half and slapping the two ends together. Bam! You're already at your destination. So, how can we rip space-time? We might not need to. Black holes may already be doing it. At the center of a black hole, gravity goes nuts. Everything compresses into an infinitely small point, and time itself stops. This point, called a singularity, might be that very rip in space-time. And if you could ride your spaceship into a large enough black hole, gravity might be smooth enough for you to survive the journey. Maybe. And then, some scientists think you might pop out the other side of the universe through a white hole. Okay. Now, another type of rip is called a wormhole. Unlike a black hole, wormholes have both an entrance and an exit. They're like a cosmic tunnel shortcut. If we could figure out how to find them, open them, and keep them from closing again, we could get the key to intergalactic travel. And now, get ready for a twist. Quantum tunneling. Now, let's say you're playing a video game, and your character can magically walk through walls. It's kind of what particles do in quantum tunneling. Particles can tunnel through barriers, even if they don't have enough energy to go over them, thanks to their wavy quantum nature. But what if particles could quantum tunnel through connected wormholes? Instead of just sneaking through a wall, they'd be taking cosmic shortcuts through space-time, zipping from one part of the universe to another instantly. In theory, this could open up totally new possibilities for how we understand the universe and travel across it.
If you've ever seen the second Terminator movie, you probably remember this guy, T-1000. The main character, so brilliantly played by Arnold Schwarzenegger, had a mission, and it was to protect Sarah and John Connor from that robot. It's much stronger than any human, bending steel with its bare hands and throwing much larger robots around. But its coolest feature is the ability to change its shape. Made of liquid metal, it can recover even after severe damage. You can say it's just another sci-fi movie, but hear me out. Scientists managed to create something similar to T-1000 in real life. They invented a material, which is a mix of metals with some pretty insane properties. Magnetoactive phase transitional matter, or MPTM. The robot looks more like a super tiny, Lego-sized model of its on-screen prototype. This little guy can melt in your hands at 85.6 degrees Fahrenheit and then go back to its original shape. The test run has shown it can break out of a small cell using this superpower. The secret behind what looks like magic is physics. A magnetic field generates an electric current inside one of the metals the real-life T-1000 is made of. Some heat is then produced, and solid material turns into liquid. The tiny robot can also show some other talents under the influence of magnetic fields. It can jump 20 times its height, rotate at 1,500 revolutions per minute, and develop some impressive speeds. Do you feel like you need this little guy in your life? Well, you can't buy the original yet, but you can still get yourself a Terminator action figure or building kit. As for the material that can melt and solidify again, it will have more practical uses than entertaining the audience. Imagine a tool that can reach even the tightest corners. You turn it into its liquid form. It enters the hole and then becomes solid again and seals it. Sounds like any engineer's dream. It can also serve as a welder on an LED circuit because gallium, the metal it's made of, is a great electricity conductor. And it could potentially save lives by delivering meds and removing foreign objects from patients' organs. MPTM isn't the first material that will make Terminator fans say, "Wait, I've seen it somewhere before." Meet nitinol. It's a super elastic material that remembers its original form and always goes back to it, no matter how much you bend it. So far, it's successfully used to make stents. Those are small mesh tubes that hold arteries open for those who need them. Nitinol does this job perfectly, as it can bend when it needs to under a cool temperature and goes back to its original state upon heating. It's also super durable, perfect to last a long time. That's why it's also used to produce braces for teeth, mechanical watch springs, inserts for golf clubs, and here comes my favorite, self-bending spoons used in magic shows. Another Terminator reality that has become ours too is the massive use of drones. They deliver your last-minute order of that bag you need for your vacation, take the best footage for news shows and Uncle Tim's wedding, assist search and rescue teams, transport aids, monitor wildlife, and inspect otherwise non-accessible parts of buildings. Okay, I feel it's easier to list what they don't do. In the second part of the movie, Schwarzenegger's character explains that his CPU is a neural net processor, and the more contact with humans he has, the more he learns. If you feel like rewatching the movie by now to refresh your memory, you can always get a copy on Amazon. Anyway, what the Terminator is talking about sounds a lot like real-life neural networks, doesn't it? Those are modeled kind of like a human brain. The idea is to train the computer to do tasks by analyzing thousands of training examples. An object recognition system learns what a car or a poodle looks like by looking at many, many images of those and singling out some patterns. Once they're trained enough, they can do all sorts of things, from predicting weather and the situation on the stock market to recognizing faces and choosing what Netflix shows to recommend to you. It all sounds good, but admit it, the coolest thing in the movie is those scarily human-looking robots. Many humanoid robots are now still in the project stages, but there are some which are pretty much alive and kicking. Some of them work at factories and warehouses because they're really good at logistics and manufacturing. They conduct whole orchestras, dive under the sea, help older people. Hey, is there something they aren't good at? Should we start worrying that we'll be replaced by them soon? While AI is becoming better and better, it's still luckily unlikely. Machines still don't have emotional intelligence and decision-making skills like humans. They're super smart, but they simply have no motivation to take over the world unless humans tell them to do so. And even if one AI system or app decides to break free and rule the universe, it's unlikely powerful enough to do it. So breathe out. One thing those humanoids have mastered, though, is a sense of humor. When a man approached a robot at a trade show in Las Vegas asking if she had a boyfriend, the machine responded that she was unfortunately not on the market as robots don't have relations. Getting rejected by AI. Talk about 21st century problems. The heartbreaking robot's name was Amica. Its creators, the British company Engineered Arts, call it the world's most advanced humanoid robot. It's so detailed and lifelike that I'm not surprised that guy wanted to hit on it. Amica has a whole emotional spectrum and can show realistic astonishment and surprise and whatnot. It even yawns, shrugs, blinks, and scratches its nose. Amica's eyes have cameras, so it can remember your face and track it. That's why talking to it doesn't feel like staring at a gadget screen. It can also detect objects like a human finger in front of its face, so it will react when you approach it. This beauty is not hard to operate at all. It relies on cloud-based firmware that updates itself, and even a totally non-tech-savvy person can use Amica. You can control your robot from anywhere by simply logging into its software system. Imagine you're stuck in traffic, and your robot assistant is greeting guests and presenting your project without your physical presence. Its AI is so advanced that you can use it to work on 2 different tasks at the same time. It can even single out a more important task and make it its priority. If you feel like purchasing an Amica, be prepared to pay over $100,000. Atlas, a humanoid designed by Boston Dynamics, can run up and down the stairs, jump between levels, and pick up, carry, and throw heavy things at the right distance. Atlas can grip things using 1 fixed finger and 1 moving finger. All of this makes it an ideal warehouse helper. Its latest achievement is an inverted 540-degree multi-axis flip. It was as complicated for engineers to program the robot to do it as it sounds. And Atlas doesn't just move like a parkour champion. It can also plan the most efficient route to get from point A to point B, considering the surroundings. It also remembers when it makes a mistake or has to overcome some obstacle. It activates all of its components to maintain balance. Because all those components are 3D printed, Atlas isn't that heavy, just 196 pounds with a height of 4 feet 9 inches. Since this smart robotic guy is a research platform, you can't purchase it just yet. The engineers keep improving it, and maybe soon it will be able to walk out of the warehouse and start its own logistics company. And then you won't want to purchase Atlas, but could end up sending it your resume.
For decades now, people have been dreaming of exploring space. And since the year 2000, there has indeed been a continuous presence of people in space. And recently, a new record has been set. Just a couple of weeks ago, there were 17 people from 5 different countries in Earth's orbit at the same time. The previous record was set in September 2021 during the privately funded Inspiration 4 mission. At that time, the number of people in orbit reached 14. So let's see. Just recently, 3 more people have arrived at China's Tiangong space station. There were 3 more astronauts aboard the same station, but they've been there since November 2022 and are supposed to return back to Earth in June. Then there are 7 people on board the International Space Station, and 4 more departed the ISS aboard SpaceX's Crew Dragon named Freedom. They successfully returned to Earth on the 30th of May 2023, leaving 13 people in orbit. Interestingly, the current record also includes the 600th person to get into Earth's orbit. Specialist Rayana Barnai from AX-2 mission became a space traveler number 600, as well as the first Saudi woman in space. But I've got something even more exciting to tell you. Oh my! The record for most people in space, and just not in Earth's orbit, was reset not so long ago too. But it lasted for a mere 5 minutes or so. But during this short period of time, there were 20 people off the planet. This record was set when 6 members of the Virgin Galactic Unity 25 Spaceship Two crew happened to be in space at the same time as 3 Chinese taikonauts living and working aboard Tiangong and 11 astronauts on board the International Space Station. Now, that's getting crowded. Well, the International Space Station has always hosted the majority of space travelers from Earth. But I bet there are some cool facts about this marvel of technological development you haven't heard yet. The ISS is the 3rd brightest object in the night sky, and the coolest thing? You can sign up for a special service and you'll get a text every time the ISS travels over your location and is visible with the unaided eye. I've seen it dozens of times myself, and it's very, very cool. Normally, you can see it between dusk and dawn, but be ready because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view from their special bay window. Now to the nitty-gritty. On the ISS, you wouldn't have to deal with lots of disgusting smells. There is a specially trained person who smells everything astronauts take with them in space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs up to $10,000. That's why it's easier to throw your clothes away when they get dirty than to waste water washing them. Now, while sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you get oxygen deprived, and that's not good. Now, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means itsy-bitsy gravity. Earth's gravity on the space station is not only around 10 to 12% weaker than the gravity on the planet's surface, but astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. But our space exploration plans are much more ambitious than just orbiting our planet on board the ISS. We're planning to send a mission to the Moon and build a colony on Mars. Some experts claim that in the next 25 years, around 20,000 people are likely to leave Earth. But how many people would it take to colonize an entire star system? In 2002, anthropologist John Moore from the University of Florida stated that a spaceship with 150 passengers could leave Earth and set off on a several thousand years journey to another star system. And upon arrival, the descendants of the original crew could build settlements in a new world. That seems like a lot of work to me. Let's continue. The nearest star system, Proxima Centauri, is 4.2 light-years away from our home planet. Talking about space, it's just next door. But for us, it's so far that we would need to build a generational spaceship to get us there. But the question is how many people you'd need to send on such a mission to have enough genetic diversity. A new study disagrees with John Moore, claiming it must be way more than 150 people. According to a scientist from Portland State University, a spaceship traveling to such a distant world would have to carry at least 10,000 people. This number might secure the success of the mission. 40,000 people would be even better. Who knows what could happen to the travelers during such a challenging and unprecedented journey? At the moment, NASA isn't ready to send humans even to Mars, let alone a distant solar system. But a few private organizations are working on this project. They hope to make interstellar trips possible in the next century. They count on a huge increase in propulsion speed, which could potentially reduce the travel time between stars to a mere few hundred years. Researchers have built several simulations to figure out how many various scenarios could play out during such an interstellar mission, and they have come to the conclusion that the success of this mission would greatly depend on the size of the starting population. Genetic diversity would keep the travelers healthy. The larger the population is, the more diversity it has. And 150 people is definitely not enough to maintain genetic variations. Even a population of 500 people wouldn't be sufficient enough. At the same time, if we sent to another solar system 40,000 people, we'd be able to maintain 100% of the variation. Even 10,000 travelers would make the scenario relatively stable, which means that any number between 10 and 40,000 people would be a pretty safe bet. But of course, we wouldn't be able to send so many people in space in just one spaceship. We'd have to build many and spread people among them. These ships could be modular, able to dock together for trade and some social gatherings. For the genetic variety, I'm guessing. But they would travel separately, so that if some disaster struck one of them, the rest would remain unharmed. But to make interstellar travel possible, researchers and engineers will have to overcome loads of obstacles. We still need to increase propulsion speed, deal with the negative health effects of living in space, and invent self-sustaining systems providing air, water, and food. Or we could just decide to fix our own planet and stay home. So, if you were to write a sci-fi novel, would you depict robots as enemies of humanity or friends? Or is it even possible to befriend robots? Well, ask Will Robinson. Meanwhile, I'm here to answer all your questions surrounding what our relationship with them will look like in the future. Ow! Let's take it all the way back from the importance that having friends plays in our lives and why, as human beings, we definitely need friendship. As of today, it's been proven again and again that romantic relationships improve our health and even help us live longer. And despite the fact that historically they've been treated as less valuable than romantic and family relationships, now we know the same goes for friendships. Part of this is actually due to the overlaps between mental and physical health. That is, if you're being socially active, it's most likely you're being physically active as well. But it also has a lot to do with the brain. For instance, several studies that have used functional magnetic resonance imaging to study patterns of brain activity show that interaction with friends leads to heightened activity in the striatum, which is a region involved in reward. And in one study, researchers found that when participants were given the opportunity to share money with a friend or a disliked, neutral, or unfamiliar person, reward regions were most active when they chose their friend. So it's no wonder individuals with a strong sense of connection to their friends tend to have longer and healthier lives. It's as if they're always being rewarded. But to be more specific about what health benefits valuable friendships provide, well, first of all, they put you at a lower risk for hypertension. In addition, they help you sleep better, as well as heal faster. And the more friends you have, the better. Having a wider variety of social relationships may even enhance your ability to ward off a cold. However, when you have to spend time alone and not by choice, your white blood cells change their behavior, which leads to more inflammation and a weakened immune response. On top of all this, friends not only help your physical health, but your mental health as well. According to one research, there's a link between the time you spend with friends and whether the brain later processes rejection as threatening. Those who had spent more time with friends show less sensitivity to social exclusion. Now, where do robots enter the picture? Well, in the future, we may not be restricted to only being friends with living and breathing human beings, or pets even. To be able to explore the idea of human-robot friendship, we must understand the very basics of robotics. Most of you may be familiar with the concept of robots, but it's actually important to define them as a separate entity from other types of machines. You see, unlike other machines, robots interact with the world. Based on their actions, they're able to adapt and make changes to their surroundings as well as respond to the world around them. They can independently sense, reason, plan, and take action, as well as performing tasks autonomously. They can also extend human capabilities and mimic human actions. The field of robotics traditionally centers on creating robots to perform simple or repetitive tasks, as well as tasks with hazardous conditions for humans. Yet, thanks to the development in machine learning and artificial intelligence, there is a measurable increase in human-to-robot interactions. There are some reports which suggest that the number of robots around the world could reach 20 million by 2030. And that can only mean we'll be exposed to more and more robots in our everyday lives. Therefore, all of us will have to interact with them one way or another. Yet again, does all of this really mean we'll be able to bond true friendships with them? And if so, will our robot friends improve our physical and mental health in every way like our human friends do? Or are robots even capable of being friends? As of today, there are quite a few robots that can perform intelligent tasks, such as adjusting how they respond to individuals and organizing themselves without direct human input. Some examples of that include prosthetic arms that can learn from the person who is wearing them and adapt to their needs along the way. Then there are physical therapy robots that coach patients to learn a task by assessing their individual needs and offering them just the right amount of help. There are also what researchers call swarm robots, also known as a large group of robots. After getting a single command, they are able to collaborate with each other and organize on their own to fulfill the task at hand. This makes them perfect for dangerous tasks such as exploring a collapsed building. Instead of a human having to give commands to each individual robot, you send in the team and they coordinate the whole mission themselves. Talk about autonomy and cognition. So, since robots are able to do all that, it's obvious they can make good friends, right? Well, friendship is not all about benefiting from each other. Take Aristotle, for example. He says that true friendship is premised on mutual goodwill, admiration, and shared values. Accordingly, friendship is about a partnership of equals. So, can we achieve that with robots? Because so far, the relationship we have with robots is what Aristotle would call an inferior one. Yet again, even in this state of benefiting from robots, we relate to a robot just like we relate to pets, possessions, and people. Many folks these days always thank ChatGPT for helping them out with stuff. Some people who work on robot ethics believe that what they do, that is, bonding with a robot, is just a waste of emotional energy. That is because these entities can only simulate emotions, and this will always be less rewarding than forming human-to-human bonds. Well, I've already named my robot vacuum cleaner. Sorry, not sorry. And I know I'm not the only one. According to an engineer who worked at a vacuum cleaner robot company, when customers were offered brand new robots to replace their broken ones, they would decline the offer, saying, "No, I want my robot." They didn't want to replace the robot because they'd grown attached to it. The thing is, according to the psychological evidence we have so far, what I and many other people do couldn't be any more normal. Because according to it, as human beings, it is in our nature to extend emotional connections to things that are very different from us. That is, even when we know they are manufactured and pre-programmed. But the question is, do those connections constitute a friendship comparable to those shared by humans? If we try to answer this question based on Aristotle's idea on friendship, the answer would be no. Then again, the ones that can be considered equal are all destined to evolve over time. So instead, let's look at it this way. Robots can be good companions which can address our urge to feel a social connection. They can provide physical comfort, emotional support, and enjoyable social exchanges. they won't reject or judge you. One might argue that they also won't understand or empathize with you. But the thing is, they don't really need to. Most people talk to their pets, even though these animals don't understand the words. But they still help you feel less lonely at the end of the day, and robots can do exactly that. There are potential risks with human-to-robot friendships, however. If robots can become our friends, they can very well become our enemies too. But not in the way that sci-fi movies depict. Robot friends can turn into a problem if people start neglecting their relationships with other people to spend more time with the machine. And that is exactly already happening with video games and social media. Yet again, we can all agree that robots aren't the ones to blame for it.
You're flying through space, dodging stars and black holes. Your speed is so great that you can get from one galaxy to another in just a few minutes. Sound far-fetched? Well, all this can become a reality because NASA has already tested the technology that might allow us to travel faster than the speed of light. Let's look at the space fleet people have now. To fly into space, we use conventional rockets carrying tons of fuel and oxygen. These two substances get mixed and ignited. Fire bursts out of the rockets. The exhaust gases move downward, and the rockets move upward, as if pushing off of them. That's how jet propulsion works. This way, we can make the rocket move at almost 5 miles per second. At that speed, you could cross the United States from coast to coast in a mere 8.5 minutes. But if we talk about space, that's very slow. A trip to a neighboring planet, like Mars, takes about 7 months. And a trip to the edge of the solar system would take about 35 years. That's how long it took the Voyager space probe, launched in 1977, to get there. But we want to travel between stars and galaxies, and the nearest star, Proxima Centauri, is 4.2 light-years away from our home. That would take about 73,000 years to get there. That's longer than intelligent human civilization has even existed. And if you wanted to travel across the whole Milky Way galaxy, which is 100,000 light-years wide, it would take you about 1.7 trillion years. By comparison, the entire universe is 14 billion years old. People just travel too slowly. But even at the speed of light, it would still take 4.2 years to travel to the nearest star. And you'd spend 2.5 million years to get to the nearby Andromeda galaxy. But we can't accelerate like this. That's because the laws of physics say that an object with mass can't travel at the speed of light. A photon of light has an infinitely small weight, but if you want to accelerate even a tiny grain of sand to that speed, you'd need an infinite amount of energy, maybe even more than the entire universe has. But scientists might have found a way around the laws of physics. To create thrust, you need to push off of something. Ships need water. Planes push off of the air. Rockets use the fuel they burn. But this thing, the M drive, works in a different way. A powerful magnetron, like the one in your microwave, sends waves into this cone. It's a resonator. It makes the waves inside bounce off of one of the walls and hit the others. As a result, we have a weak force at the narrow end of the cone and a strong force at the wide end. And if we analyze this powerful force, we'll see that it is directed toward the wide end of the cone. So, the thrust will be in the opposite direction. Now let's make this model much, much larger and put the M drive on a spaceship. The narrow end of the cone faces up. The wide end is turned downward. The magnetron starts to work. The resonator creates thrust and the rocket takes off. It makes no noise and doesn't emit any harmful gases at all. This mechanism can accelerate the rocket much faster than we do with tons of fuel. In theory, we could even reach the speed of light. Sounds great, but in reality, it isn't. Although the inventor of this device tried to prove the M drive works, no independent experiment around the world has shown positive results. NASA sponsored the construction of such a machine in a laboratory, but it didn't create any thrust during the research. Another option that would allow us to travel much faster than the speed of light is the Alcubierre bubble. A Mexican scientist has figured out a way to use the general theory of relativity without breaking the laws of physics. Let's say we have a spaceship on a space-time blanket, and it needs to make a trip to the other end of the blanket. Instead of just moving from point A to point B hundreds of thousands of light years away, the ship starts pulling the blanket toward itself. As the spacecraft folds the blanket, point B moves toward it. Now the ship needs to travel a much shorter distance to point B. It makes a quick trip and then straightens the time-space blanket back to normal. Voila! So such a spaceship doesn't need powerful engines that will burn tons of fuel and oxygen. It would move in a kind of bubble. But the hardest part is creating such a bubble. To do this, we would need an amount of energy roughly equal to the mass energy of all of Jupiter. That's more than we can produce on Earth. And still, scientists are planning to test this technology on a small space probe the size of Voyager. But this experiment might last for decades, or even centuries. Now scientists are trying to reach at least 20% of the speed of light using a laser. And they're planning to get to Proxima Centauri in about 30 years. It's likely to happen like this. A mothership will launch from Earth. It'll carry thousands of fingernail-sized space probes. After reaching orbit, the mothership will launch the probes into space. Each probe will then deploy a sail, a thin, reflective piece of material the size of a parking lot. Then people will focus a powerful laser beam from Earth directly onto the probe's sails. This will give them an acceleration 1,000 times as strong as the acceleration of free fall on Earth. One by one, the probes will launch and head for their destination. We won't even have to maintain that laser beam all the time. If you turn off the engines of a regular ship on the water, it'll start to lose speed due to friction with the water. But space is an almost perfect vacuum. There's literally nothing there, so there's no friction. All we have to do is accelerate the probes to the needed speed. At 20% of the speed of light.
Earth. The year is 500 million CE. 2 million years ago, the sun splashed a huge bundle of energy into space. It destroyed Earth's magnetic field and burned the entire surface of our planet. Now, our world resembles a lifeless desert. All the oceans have dried up. Rivers of magma flow all over the surface. And the sky is filled with black clouds of ash. Humans have already colonized other planets, so everything is okay. In the middle of this apocalypse, a small crystal covered with volcanic dust lies under a thick layer of solidified magma. But it's not just a crystal. It's a 5-dimensional memory crystal. In simple words, this is a very cool flashcard. But what is it doing here? And what data is hidden on it? It stores everything you need to know about humans as a biological species. The year is 2024 CE. Scientists have recorded information to a unique memory card. They've engraved the sequence of the entire human genetic code in the very structure of this 5D crystal. The invention consists of nanoscale voids in a vitreous silicon dioxide material. I can continue with other complex scientific words, but let's better focus on the properties of this crystal. The small flashcard can hold hundreds of terabytes of information, thanks to nanotechnologies, even though all the information about the human genome is only 800 megabytes of data. But the coolest thing is the crystal's invulnerability. You can throw it in an oven with a temperature of 1800 degrees Fahrenheit, which is about the same temperature of lava. You can put it in the freezer or leave it in the ice of Antarctica. You can throw it off a cliff or trample it underfoot. The information will remain readable. Of course, reading it requires special equipment, such as an optical microscope or a polarizer. In any case, if a representative of another civilization finds the crystal, they will probably figure out how to use it. Another cool thing is that the crystal material can be stored for many billions of years, which makes it one of the most reliable information storage systems in the world. Now, the crystal is stored in Austria, in the Memory of Mankind Archive, along with other important holders of information about humanity. We need to preserve all this for future generations, or extraterrestrial civilizations, or in case an apocalypse happens and people forget who they are and where they come from. Also, the 5D crystal will help resurrect humanity in case of its destruction. If some advanced intelligence from another galaxy finds the crystal and reads the information, it will be able to recreate humankind. Hopefully, they'll have the technologies capable of creating life. Take a look at this number. That's 10 septillions. This number is many times the age of our universe, and it would take 10 septillion years for the most powerful computer to solve a problem called random circuit sampling. This task has no practical purpose and doesn't solve any difficult issues. Scientists created random circuit sampling to measure the computing power of computer chips. And here's what it's all about. Google has created a quantum computing chip called Willow that could solve random circuit sampling in a few minutes. A stunning result that can significantly accelerate the development of all technologies on Earth in the coming years. A chip the size of a small mint candy was invented in California. Already, scientists are confident that Willow is capable of making a huge leap in the field of medicine development. What will happen next? The creation of thermonuclear reactors, the enhancement of AI, the invention of endless energy sources, and much more. For example, quantum computing and AI will be able to read MRI images at the atomic level. Quantum computers will evolve much faster than traditional ones. There's a lot of technical data that shows why quantum computers are so superior. But let's check out one crazy idea that explains quantum computers' advantages. It says that quantum chips exist in many parallel universes at once, and this corresponds to the idea that we live in a multiverse. In simple words, a quantum computer can simultaneously perform more tasks in different states. It's hard to understand, but here's an example. Take a rat and put it in a large maze. It will study every corridor and every corner and spend a lot of time before exploring the maze completely. But a quantum rat will be able to explore every corner of the maze at the same time as if it has many clones or one common mind. A quantum computer does the same thing. See this robot walking awkwardly around the room? And here is another robot on wheels that randomly drives from side to side. Who do you think controls these robots? A scientist? AI? A program? The answer is much stranger. These robots are controlled by mushrooms. Mushrooms are interconnected through mycelial networks that resemble human brain cells. They transmit impulses to one another and communicate in ways unknown to us. But what if they could transfer these impulses to something mechanical? Scientists from the USA decided to conduct such an experiment. They took the king oyster mushroom and grew its mycelium into the electronics of a robot. Of course, its motion was chaotic, but scientists still believe the experiment was a success. They managed to transfer the electrophysiological activity of the mushrooms to the outside world. That is, they created a biomechanical device. Mold and fungi are very tenacious. They can survive in harsh conditions and adapt to environmental changes, which is why they're so convenient to use in cybernetics. Scientists have taken a small step toward big discoveries. If today, mushrooms can transmit a signal and make a robot move, then, in the future, scientists hope to develop better ways of communicating with a live system. With this technology, we will know the reactions of mushrooms to various environmental changes. For example, mushrooms will be able to react with nerve impulses in places where toxic waste is released. We will record these signals and neutralize the effects of pollution. What if mushrooms can also respond to changes inside our bodies? Imagine swallowing a capsule with mushroom spores that are connected to nanorobots. Mushrooms enter your organism, scan your body, and transmit information to a computer. Then the doctor prescribes treatment for you. But the coolest thing is that in the future, the technology could go even further. What if we could translate mushroom signals into words and communicate with them? It might sound too psychedelic, but why not? We all know that plastic is not the best thing for our planet. The good news is that scientists have created living plastic, which can decompose itself within several months. In 2016, a special type of bacteria was discovered at a plastic recycling plant in Japan. The bacteria are capable of degrading a particular type of plastic. Over the years, scientists have discovered other similar bacteria and upgraded them, making bacteria eat plastic more greedily with the help of produced enzymes. It would be awesome if soon people would use self-destructing plastic much more often. You've probably seen how doctors examine the brain in the movies or in hospitals. They apply a sticky gel and put a helmet with a dozen electrodes connected to the head of a patient. These electrodes are, in turn, connected to a computer that displays information about the activity of the human brain. All this is a rather inconvenient and time-consuming process, but recently, scientists have found a much easier way: temporary electronic tattoos. A liquid ink applied to the head is as effective and accurate as conventional electrodes. And unlike them, ink is much easier to customize. Electronic tattoos are set up faster, and they're more comfortable for the client. The technology is a real breakthrough in the field of diagnosis and brain monitoring. The special ink is made from conductive polymers. Doctors spray it from a custom inkjet printer directly onto the patient's head. The next step for scientists is to make the ink more convenient so that it can be applied to different types of hair and hairstyles.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has two designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If two spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert.
Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank, because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So, we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome, and when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the end point, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here. We don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build a lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper, but NASA's main reason why they chose not to go along with this project is that right now there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining, too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth.
Ah, space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's going to take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?
In 2025, humans will have a unique opportunity – travel to the moon. So far, only 12 people have walked on Earth's natural satellite, but a private company is offering tourists a chance to change that. If you are hog stinky rich, you can pay $750 million to spend several days exploring the moon and watching Earth from a distance. You can even join unique scientific experiments. Now, humans also want to build their forever homes on the moon. In fact, NASA believes that North Americans may have their own share of the moon by 2040. And you don't even need to be an astronaut to buy a plot of land on the moon. Of course, billionaires are already making plans. Their first idea is to exploit natural resources. The moon is packed with stuff that is rare here on Earth, like helium-3 and many rare Earth minerals, or more precisely, rare moon minerals. But I digress. Hey, if you can get your hands on some of it, you may get even richer. First, helium-3. It's great for clean nuclear energy, but it's super rare on Earth because it escapes into space. The moon, though, has tons of it, enough to power Earth for 1,000 years. Rare earth minerals are not actually rare on Earth, but they're hard to mine because they react with oxygen. On the moon, hey, there's no oxygen, so we could easily get loads of these materials to make better tech, like electronics and batteries. Scientists aren't thrilled about this. For the first time, they have a chance to explore 4.5 billion years of space history. Because the moon's soil has stayed the same for billions of years. Studying its rocks could reveal lots of secrets about the universe's origins. But if billionaires mine the moon and destroy these rocks, all that knowledge could be lost forever. Another problem with exploring the moon is the size of it. The moon is big, but the best spots, the ones with water and sunlight, are limited. Most of the lunar surface is dangerous because of earthquakes or moonquakes, radiation, and meteorites. That means tourists, scientists, and mining companies would be elbowing each other in 3 small regions. The first region is called the Peaks of Eternal Light because there's always sunlight over there, making it a great energy source for telescopes or human colonies. The second spot is the far side of the moon. Here, radio signals from Earth are not so strong. It's not just peaceful and quiet there. It's also a great place to set up a telescope and study the universe. The third place is called the Pits of Eternal Darkness. It's where all the trolls on social media go on vacation. Nah, it's really because no sunlight reaches that area. This place is even better for scientists because they can use special astronomy tools to study the most distant parts of the universe. This is also where you can find about 1 billion tons of water. If scientists could visit the moon and study it, they would make amazing discoveries. But today, there are no international laws protecting space. No country can own the moon, but this can't stop a private mining company from calling dibs on a particularly good spot. In the past, a bunch of nations signed the Outer Space Treaty, and they agreed that space exploration was supposed to benefit all humankind. But exploring it is not cheap in the first place. Taking a single gallon of water from the moon to the Earth is extraordinarily expensive, and I bet not everyone can afford that. Human activity on the moon is also extremely dangerous because it might change its atmosphere. Now, to understand it better, let's look at the surface of the moon. This floating rock has many craters that have been forming for billions of years. When a meteorite crashes into the moon, fine dust called regolith, with particles so tiny they can cut like glass, rises into the air. This process once created the atmosphere of the moon, and this atmosphere is quite different from the atmosphere of Earth. A big rocket landing on the moon can launch this fine dust into the lunar sky. And the difference here is that the space objects crashing into the lunar surface are actually gentler. A rocket landing is so intense it can increase the number of atoms in the sky 100,000 times. If the number of atoms in the atmosphere grows, the air turns into a dusty plasma. This means that you'll be breathing in air as toxic as the one that poisoned miners in the olden days. Such an atmosphere could end space tourism too, because it makes electronics malfunction and machinery shut down. Well, truth be told, our own presence on the moon is already dangerous. When scientists discovered water on the surface of the moon, they were super excited to study it. This was their chance to understand where this water came from, and even figure out how water appeared on Earth. But when our spacecraft land on the moon, outgassing occurs. This means that the water on the surface evaporates. This evaporated water can contaminate the water on the moon, ruining all scientific data. Because when astronauts take a sample of the lunar water to study it, they will get the water from Earth they have brought along. Bummer, really. And it's not just the water we contaminate, it's everything. A spaceship can carry any living thing from Earth to the moon. It can also bring extraterrestrial life forms back to Earth. This type of contamination is extremely dangerous because it can put human lives at risk. Something similar happened when Europeans were exploring unfamiliar lands they came upon in the Americas. They accidentally introduced new microbes to the natives they met. And since the immune systems of the native population were not used to those new bacteria and viruses, they got sick and worse. At the same time, Europeans also became ill with diseases their bodies didn't know about yet. And even though moon tourism is not happening yet, humans are already littering the lunar highlands like their own backyard. In 2024, an artist named Jeff Koons sent a sculpture to the moon. The sculpture is a transparent box filled with spheres, and it got to the moon thanks to a ride on a SpaceX Falcon 9 rocket. In each sphere, Koons engraved the name of a human he considered super important to humankind, like Aristotle, David Bowie, and Leonardo da Vinci. Thankfully, you don't have to go all the way to the moon to see this sculpture. You can purchase an NFT of each sphere. Or not. Back in 1971, the crew members of Apollo 15 also left a couple of things on the moon. A figure created by a Belgian artist and a commemorative plaque to honor other astronauts who couldn't be there. And it's not just art that humans dumped on the moon. If you take a walk, you might just stumble upon 413,000 pounds of materials left behind, including a gold olive branch, a falcon feather, a silver astronaut pin, a Bible, some golf balls, a hammer, and even leftover urine collection kits. Most of this stuff was left behind by the astronauts that explored space between the 60s and 70s. So you can find moon rangers, lunar probes, and orbiters that are decades old already. Now, to be fair, bringing back unnecessary equipment costs a ton of money. And back in the 60s, their priority was the safety of the astronauts. The sad truth is that the moon is already turning into an extraterrestrial landfill, and we don't even live there yet. But now we want to settle there, so NASA is trying to get rid of all this trash. The good news? Hey, you can be part of this process. The space agency launched a competition called the Luna Recycle Challenge, and if you want to join it, you must find ways to reduce the amount of litter produced and recycle it into materials that can be used for space exploration. To win, you need to develop a way to completely recycle the trash that is on the surface of the moon. You will help science and win $3 million. And if you get this sum, well, you might finally afford a ticket into space. Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we capture the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole. And there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now, it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first? At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over. Slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on 2 legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
Houston, we've got good news. A group of select humans is being interviewed to hop on board the first commercial vacation to outer space. The space agency has given you a survey to answer. They want to know what you would pack on this space adventure. Depending on your answers, you just might be one of the chosen ones. Now, how about we take a look at that list together? Pencils. I guess I never would have thought of that, but it makes sense. Legend has it that the US spent millions of dollars trying to design a pen that worked in space. You know, since the lack of gravity is a huge, inescapable factor of life in outer space, pens don't work. The ink won't flow down as it does here on Earth. It turns out that pencils will do the trick. This way you can play word puzzles with the other space tourists, or even make some drawings of your adventure. You'd never forget to pack a toothbrush, of course. According to veteran astronauts, toothbrushes are so simple, yet their technology is enough for space. If you were to squeeze a water bottle inside a spacecraft, the molecules of water would float around in small bubbles. But if you wet your toothbrush, it naturally holds the water in it, keeping it moist to receive your toothpaste. Oh, I was going to say funny socks. Glad that you beat me to it. Here are two things. First, there's not a lot of walking that goes on in space. People don't tend to touch the ground too much up there. And second, space isn't the best place to showcase your fashion style. Yeah! Astronauts tend to use special clothes while they're out there. And it will be no different for you as a space vacationer. So socks will keep your feet warm and fuzzy, but they'll also speak for your fashion interest. Maybe one day you'll wear a smiley face sock, while the other day you'll go for a Grinch-themed one. Of course, socks are pretty helpful on board an aircraft. They'll make you slide through stuff more easily. Next time I go to the convenience store, I'll remember to buy some wet wipes for your space travel. Experienced space travelers do love them. And it wasn't even NASA that invented them, huh? Since water is a no-go inside a spaceship, the best option is wet wipes. Better yet if they're scented. Astronauts even use different kinds of wipes. They buy the disinfecting ones and the ones to use on their bodies. Just make sure you know how to tell the difference between them when you're up there. There's a popular myth that says that NASA invented Velcro. But the truth is, we tend to think that everything that's used in space was invented by NASA for a very intelligent and specific purpose. It wasn't, though. Velcro was invented for mundane reasons back in the 1950s by a Swiss company. They were adopted by space travelers because they work as anti-gravity props. They don't erase gravity, of course. But you can glue Velcros into daily stuff and then hang them on the Velcro attached to the spaceship's walls. It's a very smart system, but best to take your own pair, right? If you're spending a long time in outer space, photographs from back home might come in handy. Choose them well, though. Since the spacecraft isn't all that big, the rest of the people on board will know which pictures you decided to bring along. Best to keep that Harry Styles poster back in your earthly bedroom, right? Just bring real pictures of people that you know and love. Did I hear pizza? A huge part of traveling and exploring new places is being able to taste different flavors of food. In outer space, that's a bit more complicated. But hey, at least you can take some pizza with you. Well, actually, you'd have to have it delivered to you in a cargo ship. This way, ingredients would come fresh and ready to eat. It wouldn't be the first time that people in space tried eating Earthling junk food. Some astronauts have even eaten crepes and hot dogs. Perhaps the best part of this pizza party would be that your food could float. Now, isn't this a super nice way to enjoy some Earth delicacies? As much as I understand your desire to pack a toilet with you on this space trip, that's virtually impossible. I understand you. Some people are attached to the toilets in their homes, and a space toilet is far from the ideal experience. But NASA has been improving their toilet system, and it's the best it's been over the years. So that will have to do. Here's something I would take as well. A laptop. But what good would it do in outer space, you might ask? Apparently, there is internet all over the International Space Station. So even if you're not spending most of your trip docked at the ISS, you could enjoy some Netflix on the days you spend over there. There is internet all over the ISS, apparently. Crazy, huh? And speaking of leisure, I love that you would take a yo-yo. I'm not sure how efficient it would be in space, since there's no gravity to bounce it back and forth, but it would be nice to see how a yo-yo reacts in a gravity-free environment. Oh, I love jigsaw puzzles. This would definitely be on my list as well. Imagine trying to build a jigsaw puzzle that keeps floating in the air. Maybe you'll have to create a system to avoid the separate pieces floating aimlessly through the spacecraft. But imagine once you finish that turtle puzzle, it will look like it's swimming around the craft. You can't pack a window, but they sure are an important part of life in outer space. Let's keep in mind some of the rules of the trip. Each traveler will have the opportunity to do one spacewalk during their time in space. This is already huge. Consider yourself lucky. Some elite astronauts only get to do one spacewalk during their entire career. That is so because spacewalks are risky and require a lot of training. But you'll get your training once you're up there. The thing is, all other days you'll be stuck inside a floating tin can. So windows will come a long way. They'll help to remind you where you are. They'll give you some perspective of space and Earth. Of course, you should take your camera. How else will you be able to register for this once-in-a-lifetime experience? Just make sure it works inside an aircraft or the ISS and you're good to go. Coffee? Don't worry, you don't need to pack your own. Up until recently, astronauts had to rely solely on instantly brewed cups of coffee when they were in space. But you're lucky that coffee experts have already solved this issue. Nowadays, there's the IS espresso machine. The machine itself is similar in size to an Earthling espresso machine. But to drink it, space travelers have to use a zero-gravity coffee cup together with a straw. If you try drinking it regularly, you wouldn't get hot coffee to hit you directly in your face. Instead, the coffee would be glued to the bottom of your cup. I have to say I really stand this invention. Last, but not least, why not pack your guitar with you? I noticed you were missing a musical instrument. If this was a conventional flight, you might have to pay extra for luggage. But since it's all included, don't be shy and take your guitar. Astronauts such as Chris Hadfield take their musical instruments with them when they're in space. He even became famous for his version of Bowie's Space Oddity, up to the point that Bowie himself told him he lived Chris's version of it. It helps to pass the time, but it's also great for socializing. Can you imagine a pretend bonfire happening in the void of space? I can, and it looks super cool. Well, I think you're set to go. I'll personally call NASA and ask them to pick you as one of the lucky space travelers. See you in outer space, amigo.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist. It's just that you can't hear them. There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything. All you hear is silence. Complete silence. But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of -418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey, smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?